this is a session on probability, being the last chapter, and this doesn't have much to understand really. Basically, there are few terms which you need to be acquainted with. One being this elementary event. What is an elementary event? That is an outcome of a random experiment, is called an elementary event. What are the possible outcomes? Like, let us take up an example. When I'm tossing, somebody is tossing a coin, there are possible two outcomes. Either when you toss a coin you get a head, or you get a tail. So this two, that either getting a head or getting a tail, are the elementary events associated with this experiment of when we are tossing a coin. Secondly, the term might be, let me just note down the terms we are discussing. One I said was elementary event. Then what a compound event. Compound event, what is it? An event associated to a random experiment is compound event if it is obtained by combining two or more elementary events. The top one we discussed was elementary event. When two such elementary events got combined, then it becomes compound event. What else can be discussed? What is the theoretical probability of an event? Theoretical probability of an event says, if there is n elementary events associated with a random experiment, and it says, I'll just note it down, m of them are favorable to an event A, m is favorable to an event A, then probability of I'll just erase that part, or I do write down. What does that mean? Theoretical probability is defined as the ratio of m by n. So we call probability of an event A is given by m by n, where m should be more than 0 and should be less than n. Now we take up few questions on probability that might make us clear about how to represent the probability. The first one being pretty simple one, which I will be writing: an unbiased die is thrown. What is the probability of getting? First one says an even number. Let me just solve simultaneously rather than writing the whole question at one go. In a die there are numbers like 1 to 6. There being, I'll just note it down here. So 1, 2, 3, 4, 5, 6. When we are throwing a die, out of all these 6 options, we might be getting 1. So the even numbers being 1, 2 and 3. So when you are throwing a die, getting an even number will be 3 out of 6. So the probability being m out of n. Sorry. Favorable being 3 and the total possible outcomes being 6. So that can be reduced and being expressed as 1 by 2. Number 2 says a multiple of 3. So the probability becomes, let's count which are the possible outcomes when the probability is the number we get on dice is a multiple of 3. So it can either be a 3 or 6. So there are two possible outcomes, or two favorable number of elementary events by n being the total number of outcomes. That makes it 1 by 3. Third one in the same question says it is an even number and a multiple of 3. It has to be even number and multiple of 3. Now out of multiple of 3 we could see that there were only the ones which I'm underlining. This one, 3 and 6 are the numbers which are multiple of 3. Out of them being even number is only 6. So there is only one elementary favorable number of elementary events. So probability will be expressed as 1 by 6. The next question in that part becomes a number between 3 and 6. Between 3 and 6, so there are two numbers which is 4 and 5. So it becomes 2 by 6. Favorable number of outcomes being 2 by 6. That gives us 1 upon 3. One more we can take up here says it is an even number or a multiple of 3. So this is different to the third one which said it is and a multiple of 3. It has to be an even number, so the possibilities being 2, 4 and 6, or a multiple of 3. So that also would include 3. So that makes the probability being 4 out of 6, that is 2 out of 3. Let's move on to take up another question. Now the question writes 3 unbiased coins are tossed together. Find the probability of getting, first one reads all heads, then it writes 2 heads, then it writes 1 head, and the fourth part is asking about the probability when it's at least 2 heads. When we are tossing 3 coins together, what are the elementary events associated with random experiment? So either the possible one, I'll write it here. So it is either a head, head, head for all 3 of them, or it will be head, head, tail, or it is head, tail, head, or tail, head, head, or head, tail, tail, head, tail, tail, then I'm missing something, yeah, tail, head, tail, and it can also be all 3 tails. So these are the possibilities. These are 1, 2, 3, 4, 5, 6, 1. This is head, 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 tail, tail, head, head, okay. Tail, tail, oh, there's one, I think I missed it, that can also be tail, tail, head. So these are the elementary events. Now getting all heads. This is the only one case where we are getting all heads. So the probability becomes 1 out of 8. And then getting 2 heads. So 2 heads can be here, here and here. So 3 out of 8. Only 1 head is somewhere, I think here, here and here. That also is 3. And at least 2 heads. That means it can either be 2 heads or more. So here you have 2, here you have 2, 2, 2. So it's 1, 2, 3, 4. Only 4 cases where it is at least of 2 heads. Let us take up another question. It says, find the probability that a leap year selected at random will contain 53 Sundays. In a leap year, we know we have 366 days. Thus, in 366 days, that might have 52 weeks and 2 days will be left. Sorry, I'll clear it out. We might have 52 weeks and 2 days left. So thus a leap year has always 52, as because 52 weeks are there, it's it's quite clear that a leap year will surely have 52 Sundays. Now these 2 remaining days can be a combination of any 2 days, right? That might be Sunday and a Monday and a Tuesday, Tuesday and Wednesday, Wednesday with a Thursday, Thursday with a Friday, Friday and Saturday, and with a Saturday and Sunday. So now out of these 7 7 combinations, the possibility of getting Sundays are only at these 2 steps. So here the possibility will be 2 out of 7. So the required probability being 2 out of 7. Being under probability, it's quite common to come across questions on cards. So the next question is on cards, that is the king, queen and jack of clubs are removed from a deck of 52 playing cards, and being well shuffled. One card is selected. Just ignore that spell mistake. One selected. One card is selected from the remaining cards. We have to find the probability of getting first one being a heart. Now after removing king, queen and jack of clubs from 52 playing cards, 3 cards are removed, so 49 will be left out. Now out of this 49, 1 card is chosen in 49 ways. That means the total number of elementary events being 49. Now to get a heart, so there are 13 hearts, so the probability being 13 by 49. The second being it's a king. Now out of 49, there cannot be the king of clubs that has been taken out, so 3 are left out of the 4 decks. Third one says it has to be a club. Now out of 49, and out of the 13 cards of club, 3 are already been taken out, so 10 are left. So it is 10 upon 49, and the first part being the 10 of hearts. So out of 49, that can only be one card, which is 10 of hearts. Hope you followed all the questions. More on the practice will help you do that better. Thank you.